Okay, I'd like to introduce our next speaker, who's Joseph Gottlieb. Dr. Gottlieb is an assistant professor in the Department of Philosophy at Texas Tech University. His research interests include philosophy of mind, cognitive science, the history of early modern philosophy, existential risks, and the ethics of space colonization. And he will be answering the question, hopefully, should we colonize interstellar space? I'll pass it over to you. Thank you.
I'm not going to answer this question, by the way, so sorry to disappoint. So I suspect that for pretty much all of you, the answer to this question is settled. But I just ask you to humor me for about 20, 25 minutes, okay? All right. So I'm going to begin with some background points that's going to help shape the kind of question I'm actually asking and the assumptions I'm making. So the titular question, should we colonize interstellar space, has different interpretations. So for instance, personally, I think large-scale, self-sufficient space colonization would be incredibly exciting. And for lots of people, that would be enough to answer the titular question in the affirmative. But that's not what I'm interested in. I'm interested in a moral question. Despite the title, not a deontic question about our obligations, but just about what would be best. And what would be best and what our obligations are can in principle come apart. But I want to start first with what would be best. In particular, I am interested in the relationship between space colonization and our having a positively valuable future. Now that question, in fact, breaks down into two sub-questions. What is the relationship between space colonization and having a future that is not going extinct? And what is the relationship between space colonization and having a positively valuable future? These questions are conceptually distinct. It could be, for all we know, that space colonization is required to stave off extinction, but for some reason, the mechanism behind this locks in a bad future. Okay, so that's the kinds of question I am interested in asking. Now, when I talk about what's best, I'm a philosopher, an analytic philosopher by training, so we call this a value theoretic question. So we need to talk a little bit about value. So what makes an outcome, for example, a future where we colonize space versus one where we do not, valuable? Unsurprisingly, this is a really complicated issue. There is no settled answer here, certainly not in ethics. But I think, an assumption that I'm going to make, and I think a reasonable assumption at that, is that a primary determinant of the value of an outcome is the well-being in that outcome. That is how well things go for conscious sentient creatures like us, and perhaps distributional facts about well-being. Now, I'm not going to make any assumptions about the nature of well-being. There's different theories about what well-being consists in, pain and pleasure, desire, satisfaction. There could be just objective facts about what well-being consists in. But I do want to make an assumption about what it's required to accrue welfare of any kind at all. And that's that we have to have either consciousness or at least mentality. So what that means is to be a welfare subject, to be the kind of thing that can be better or worse off, the kind of thing that can be harmed, the kind of thing that can accrue welfare, you have to at least have the capacity for mental states or the capacity for consciousness. And if that's right, what we are striving for is an outcome where there are as many conscious beings as possible with as much positive well-being as possible. So what I'm thinking about with respect to space colonization and this moral question is how the possibility of space colonization intersects with that outcome. Now, there's different views out there, obviously, about the moral importance of space colonization. So we might distinguish between three different positions. On the one hand, the space colonization optimists says that space colonization will be, on balance, an unambiguously good thing, and that we should do it as soon as possible. Maybe that's the dominant view here. On the other hand, the space colonization pessimists will say that, on balance, space colonization will be an unambiguously bad thing, and we should not do it even when we have the ability to do it, including, of course, interstellar colonization. Then you might have a middle road, which we'll call decelerationist. And they say that space colonization is not unambiguously a bad or good thing, maybe good on balance, maybe bad on balance, but we certainly shouldn't jump at the chance even when we have the ability to do so, right? We need to exercise due caution. We need to think things through. We need to mature. I think that's a respectable position. I'm not, in fact, going to well, in a way, I'm sort of going to bend things towards the optimist, but I think the decelerationist is a completely respectable position. Most recently, though, Daniel Deudney can be read as offering an extended argument for pessimism, although I'm not sure he would explicitly endorse the view as stated. Finally, I want to talk about that first sub-question, whether we'll have a future at all. So, lest there be any confusion, extinction would be very, very bad. So I think that's fairly obvious, but what's less obvious is why it would be bad. And this is really, really important to me, and I think it's a really important point to grasp, especially for some of the things I'm going to say later. My view on this question about why it would be bad, and it's not original to me, is that it would be bad not just because the extinction event would kill everyone alive at that time, but because extinction would foreclose our future in its entirety. And indeed, I'd suggest that it's this latter feature that really explains the unique moral badness of extinction. Now, this idea comes from a philosopher who passed away a few years ago, one of my favorite philosophers of all time, named Derek Parfit, in his 1984 masterwork. So the way he explained this was he had us think through three different scenarios, and I'm going to put them up here. So in the first scenario, we have peace. In the second scenario, we have a nuclear war that kills 99% of the world's existing population. And then third, a nuclear war that kills 100%. Now, I suspect everyone would agree that 3 is the worst outcome and 1 is the best outcome. But what's really interesting here is the relative difference between these outcomes in terms of badness. Parfit thought that the difference between 2 and 3 is greater than the difference between 1 and 2, precisely because of the unique badness of extinction. And I tend to concur. And there's, in fact, been some recent psychological experimental work about people's just general opinions about this scenario, and it's really depressing, because I think it's just quite obvious that I shouldn't say quite. Philosophy is complicated. Everyone disagrees. To me, it's obvious that the relative difference is quite worse, just as Parfit described it. And this really matters. So, what's the immediate upshot of this? I think the immediate upshot, or maybe with a few intermediate steps, which I'm just going to gloss over, is this. In expectation, the value of the future is astronomical. What that means is that protecting the future, which is 1, ensuring that we have one, and 2, ensuring that it goes well, because you could have one, it can be really bad. We don't want that. Right, is of paramount importance. Anything you care about, anything you value, in expectation, there is a vast amount more of that stuff in the future. So from an impersonal standpoint, from an impersonal moral standpoint, this is very important to appreciate. So the question I'm asking is, what role, if any, does space colonization play in protecting the future? Now, again, I'm not going to answer this in finality, but I do suspect that working through this question would help us decide between optimism and pessimism, right? So, for instance, if space colonization would actually hasten our extinction, that would be bad, right? That would be a point in favor of the pessimists. So I can't settle this issue, but I do want to think through some key points. So first, I'm going to talk about the promise of space colonization. First, in terms of having a future at all, and then having a good future. So when we think about extinction, why should we be worried? This is something that keeps me up at night. I think we are potentially at the hinge of history in the next 100 years, and it's treacherous. So what are our threats to the future? Well, under the category of existential risks, we have things like nuclear war, climate change, supervolcanic eruptions, stellar explosions, engineered pandemics, and unaligned goal-directed artificial intelligence. Now, not all of these risks are, strictly speaking, extinction risk, but they could devalue our future. So I don't think we would literally go extinct, for instance, through climate change, but it would be very, very bad if we get into some of those worst pathways. So when we think about pursuing space colonization to ensure that we have a future at all, we want to think about how it works on risks like these. Now, I think there's a fairly intuitive thought, right, about not putting all of your eggs in one basket. That's the intuitive idea, right? But it's more complicated than that, okay? So let's say that two settlements, S1 and S2, are catastrophe independent if a catastrophe on S1 would be unlikely to result, or not result at all, in a catastrophe on S2. This requires not just sufficient distance between S1 and S2, but that S2 is, of course, self-sustaining and developed enough to carry on the human story. So here's the intuitive thought, I think, made a bit precise. Premise 1. For any event E to cause either civilizational collapse or literal extinction, there must be no catastrophe, there must be no catastrophe dependent, you get the idea. Sufficiently scaled space colonization will vastly increase the likelihood that for any E, there is at least one catastrophe-independent human settlement. Therefore, space colonization will vastly lower the likelihood that for any E causes either civilizational collapse or literal extinction. So I think this is the intuitive thought rendered precise. The problem is that the argument's not sound. The second premise is false. And I think that's where thinking through the various risks is really important. So it really depends on the E, or the risk we're talking about. And I think, in fact, sadly, it's probably false for the most severe risk, which in my opinion is unaligned artificial intelligence. The key issue is that we need to think about risk correlation across settlements. Now, answering that will depend on what the settlements look like, about things like chronic distance between settlements, which, as we're going to see, is a bit of a double-edged sword on its own. But not depending on how these settlements are constructed will have a huge impact on whether one catastrophe on one settlement will impact another settlement. But there are some risks, like unaligned artificial intelligence. By here, I'm talking about specifically goal-directed artificial intelligence, agentic artificial intelligence, where it does not matter. It does not matter. What I think that shows, though, and this is the optimistic point, is that space colonization is not enough to stave off extinction. It's a necessary condition, perhaps, but not a sufficient condition. But that means it still nonetheless plays an important role. We could think of it as removing the portion of uncorrelated risks from the total risk space. That's the way to think of the role of space colonization in staving off extinction. Now, what about making the future go well, right? Again, that's independent from us having a future at all, right? So you might wonder whether we should focus on increasing the probability that the future goes well, assuming we don't go extinct. Now, there's different frameworks for thinking about this, and I'm going to be a bit breezy here for the sake of time so we have room for questions. One way to do this is to compare a normative bads to goods exchange rate with one's empirically expected goods to bads ratio. This comes from a philosopher named Althus. So on this view, on an N ratio greater than 1:1, reducing bads is more important than increasing goods. On an E ratio greater than 1:1, there'll be more goods than bads in expectation in the future. So when you weigh these things together, depending on how the numbers shake out, you could have an upside focus or a downside focus. And that will determine the actions you take to protect the future, whether you're focused simply just on extinction or just making sure the future goes well, assuming we don't go extinct. Now, on that latter route, and so we can talk about this later, how you determine your N ratio. Well, let's just do it. This is interesting. So if you're curious about N ratios, imagine you create a new world inhabited by X humans living in a utopian civilization, free of involuntary suffering, and where everyone is extremely kind, intelligent, compassionate. In this world, however, there also exists 100 humans who experience extreme suffering. So you want to know your N ratio? Just do this. Ask yourself, what's the smallest value of X for which you'd be willing to create this world? The higher X is the higher your N ratio. This is a very thorny issue in ethics. But it turns out that it's really hard to justify absent controversial views like negative utilitarianism. The point I want to make here is just that I think that even if you have a somewhat high ratio, there could be reason to expect a high E ratio, assuming we do colonize space. In other words, we could expect more goods in the future on space colonization. So there's a few ways we can think about this. So I mentioned welfare subject before. Guess what? Humans are not the only thing that matter morally, right? Non-human animals matter morally too. And we might imagine, for instance, space colonization serving as a massive driver for things like in vitro meat, right? In space, cows and pigs are kind of hard to pull off, right? In addition, we could think about sustainable rate of economic growth. Some economists like Tyler Cowen thinks that is really critical to shaping a positive future. So right through asteroid mining, things like that could be greatly facilitated by large-scale space colonization. And then, of course, there's new technological discoveries that could vastly improve quality of life that spin off from novel problem solutions. So we have historical examples of this through the space programs we've already had. Okay, so I want to briefly talk about the peril, okay, before I run out of time. So a really important point here, and we mentioned this earlier, is chronic distance. And I think there's a sense in which, as the radius of space colonization expands, things get harder. So Kohler argues that chronic size is a key determinant on the size of sovereign political organizations. And that's a function of metric distances and technological and contextual factors. Roughly, the idea here is that the relationship between space colonization and existential risks is related to potential anarchy and the inability to craft a cosmic leviathan. And distances between settlements make this very challenging, and they contribute to things like value drift and collective action problems. And we could actually think about this, the size, the chronic limits of the governable universe. So Kohler estimates that it's about 6 light months. That makes a colony on Mars fall well within the range of a governable universe, but say we want to go to Proxima Centauri, and that's going to be a problem. Absent, for, of course, exotic propulsion techniques. But like, even with the exotic propulsion techniques, depending how far we go out, right, we still have this governing problem. And then, of course, right, there's Daniel Deudney, who has a very systematic argument. I'm going to skip these quotes. So he basically what he does in a nutshell is he lists out 6 different ways: malefic geopolitics, nuclear threat amplification, restraint reversal, hierarchy enablement, alien generation, and finally, monster multiplication. So I'll refer you to the book to take. It is a great book in many ways. It's worth working through. Here's his view in a nutshell. He thinks, and this is why I read him as a pessimist. He thinks that space colonization will introduce new threats and exacerbate old ones. That's his view in a nutshell. He's not wrong. He's not wrong, by the way. He's not wrong at all. But that doesn't settle the issue. It doesn't obviously justify pessimism. So, I mean, a technical point. For one thing, it's not actually clear that there's 6 ways. A lot of these are intertwined. It's not obvious that we can disentangle, for instance, natural threat amplification from some of the other conditions. But I think the crux of the issue isn't even that. Rather, the crux of the issue when it comes to protecting the future is not whether space colonization will exacerbate and create some new risks, but will pursuing space colonization increase or decrease total X risk relative to not pursuing space colonization? And in addition, it seems like several of the risks will arise even in the world path where we don't pursue space colonization, things like alien generation. And then another example that's actually noted by Deudney is artificial intelligence as an instance of restraint reversal. Now, I think current trajectories make this moot, but also it's a bit of an odd position because I think we have things backwards. Space colonization might not result in AI, but AI might result in space colonization, especially of the interstellar variety that we're actually interested in. So I have a lot more to say on this, and I have an appendix of slides that we can go into some of the more technical details, but I just want to end with a few thoughts. There's a slogan associated with so-called person-affecting axiologies that goes like this. We are in favor of making people happy, not making happy people. I think that's wrong. Why I think it's wrong is a longer conversation, but it's wrong.
Thank you for that. That was it was interesting. Brought up a number of interesting concepts. Before I ask the question, I'd like to posit three things. The first is if in terms of like the percolation hypothesis that we travel about 1/10 of the speed of light, eventually within a couple million years, we can colonize the known galaxy. And the other one is the rare earth hypothesis of the great filter, that we may be an early adapter and we may be virtually alone in the galaxy. So if you posit that and you say life is by its nature aggressive, don't we have an imperative to expand as fast as possible? Because if there's another intelligent civilization out there doing the same thing, let's say on the other side of the galaxy, they may be employing something akin to the manifest destiny for them, and that we will have to meet them somewhere. And if they're aggressive, and one of their optimal results of finding an intelligent civilization is just to wipe them out, shouldn't we get out there first and grab as much real estate as possible?
Yeah, so it's interesting. So of course, so part of me would be less interested. I mean, I actually do in fact think we're probably alone. I think that's my first or second favorite solution to the Fermi paradox. But supposing we weren't, I tend to think that, and this is gonna get some boos. I tend to think that if there are other conscious sentient creatures out there, there's actually less of an imperative for us to colonize space. There's a less because consciousness is already out there, and that's what accrues value. On the other hand, I do like humans, and I want the human story to continue because I do think, although I don't know how to express it, there is something special about the human story. I mean, like, are you asking, should we grab real estate on this conditional on other people doing it as well? Well, the universe is pretty big. I think there's room enough for us. My bigger concern is what happens when those civilizations meet.
If you use game in terms of game theory.
So you're referring to dark forest theory? Is that what you're referring to? Because we could talk about that later.
Right. If you think about this in terms of game theory,
yeah,
what are our optimal moves? And since you have other intelligent actors acting on this information, one of the most optimal things they can do is colonize as fast as possible. Isn't that also our optimal move? I mean, other than the morality, the ethics, and the survivability of us colonizing other worlds, isn't that an optimal move that humanity must take?
From a game theoretic perspective?
Yeah.
No. I don't think so. I don't think so.
Great talk. Jacob Buckminster, Blue Marble Space. So you mentioned Derek Parfit. I just wanted to ask about the non-identity problem.
Yeah.
We have like 9 billion people on Earth today. Imagine 1 trillion people living in space with lives barely worth living. Is this a good future?
If you adopt a totalist axiology, which Derek Parfit does, then yes. And I think so. There is no axiology. I'll try to be quick. There's impossibility theorems that show that there is no axiology that satisfies all of our intuitive desideratum. And totalism, the deficiencies like the repugnant conclusion that come from totalism can be explained away. So totalism is a shitty view, but it's probably the best of the shitty views. But I think the long-term, the astronomical value of the future holds up on other axiologies like averagism as well.